In this video, you are going to learn about literal equations. Literal equations are just regular equations. There's just a lot more variables to solve for in there. So we're just going to use our inverse operations to solve for the indicated variable, just like we would in any other equation. So if you notice in your examples, I broke them down into a regular example and then what they technically could look like as a literal equation. So if we look at the literal equation first here, it says x minus b equals a, solve for x. So our goal in the end would be to get x by itself. Now if we look at the same type of equation here, just in regular equation form, the way to get x by itself would be to add 7 to both sides. Therefore, x would equal 15. So when we look at this one here, we would have to get x by itself to add b to both sides. And then a and b are not like terms, so it would be a plus b. So x just equals a plus b. In example 2, our literal equation says b times x equals a, and we want to solve for x. Well, let's look at what we would do in a regular equation that looks just like it to solve for x. So to solve for x here, since 4 and x are being multiplied, we would want to divide both sides by 4 to get negative 3. So in the same type of equation over here, since b is getting multiplied by x, I want to divide both sides by b to get x by itself. And a and b are not like terms, we can't simplify that, so we just leave it as a over b. Same thing for example 3. X divided by b equals e, and they want me to solve for b. I'm going to change this and say solve for x here. So you can just fix that too to say solve for x. So since x is being divided by b and to get an x by itself, just like we would do over here, we would multiply both sides by 5. X would equal some really big number, 3,125. Over here I would multiply both sides by b, and x just equals b e, because that's what it would look like multiplied together. Okay, in the next few it's going to now just be some two-step equations. So we have 1/2 of a plus b equals c, and I'm solving for a. My goal is to get a by itself. If we were to do the same thing in our regular equation over here, 1/2 x plus 4 equals 8, I would technically subtract 4 on both sides, because I would always have to add or subtract first with inverse operations. So I'm going to do the same thing here. I'm just going to subtract b. I now have 1/2 x equals 4 over here. And I have 1/2 a equals, and just like in our first example, c and b are not like terms, so it's just c minus b. 1/2 of x equals 4. So just like before, I would multiply both sides by 2. X equaled 8 over here. I would multiply both sides by 2 over 1 over here. Now be careful, since there's two things over here, I need to multiply them both by 2 over 1. X equals, the correct way to write this would be to put the 2 over 1 in the front, and I technically don't need the 1 on the bottom, and that would be my final answer. Okay, same thing for my next one. It's almost in the same setup. Ax plus b equals c. I'm solving for x. 2x plus 5 equals 11. Always first thing you want to do is add or subtract because it's inverse operations. So just like I would subtract 5 over here, I'm going to subtract b over here. Now my next step over here would be just to divide by 2 because I want to get x by itself. I need to divide by a, and I need to divide this entire side by a. So x equals c minus b over a. Alright, Alright, our last example includes a squared. The opposite of squaring is square rooting. So the first thing I would want to do on this equation over here to get x by itself would be to divide by 8. Divide by 3 on both sides. And since I'm solving for y over here, I'm going to divide both sides by x, leaving y squared equals z over x. The opposite of squaring is square rooting, so I'm going to square root the entire both sides. They cancel, and I can just leave my answer like this, and same thing over here. They cancel, so I can just leave my answer like this. Alright, let me know if you have any questions.